class, and welcome to my Math 355 project. For my project, I'm going to be discussing the idea of cognitive thinking, the idea of gaining knowledge, and how comprehension works in the world of calculus. So you might be asking yourself, what is cognitive thinking? Well, cognitive thinking is the idea of gaining knowledge and how comprehension works. Calculus, the overall study of it, is the rate of change. When you put these two concepts together, we understand that as we grow, our brains also grow, and the way we see the world. And we can use problem solving, remembering, and interpreting ideas as a key factor in how we understand how we gain knowledge. No matter we take our memories from our childhood, from our memories to now, we put these things together and we understand that the rate of change of how we grow also affects the rate of how we think. So the model that I chose to discuss for my math portion of my project is topological models. And the model that I have here is from a source called An Introduction to the Cognitive Calculus, a Calculus of the Mind. This model overall, as we can see, is a very good distinguish of a continuous model. We can see how the letters Z, X, Y, and B are capitalized, and they are very significant in our project here. As you can see, Z is more of the overall aspect of the diagram. We can see that Z is the starting factor as it is the top left, and we can see that its arrows are starting from there. As we can see overall from our problem, Z is in relation to X, Y, and the results are B. As we can see at the end, it tells us that B is the product of X and Y. And we can see overall that Z, X, and Y are all in relation overall, no matter where they begin or how they are interpreted, whether with B, whether with X, or whether with Y. This idea overall comes into the fact of cognitive thinking as we can discuss total memory. Total memory is broken down into three different parts. We can talk about short-term memories, we can talk about our episodic memories, which are our life experiences, or we can go into the idea of the abstraction memories, which is applying what we know and how we grow as human beings. Overall, I use this diagram to relate back to total memory in the sense that Z is the overall total memory, X is our short-term memories, Y is our episodic memories, and B is our overall abstraction memories. Abstraction memories is based on the following two above it, because without our short-term memories, without our life experiences, we wouldn't be able to apply what we know without having to learn them from the start. And this idea is really important with the model because the model clearly distinguishes that no matter if you begin from the right side going to the Y or going down to X, we overall will always land at our product B. And this idea is very significant to calculus as the rate of change, no matter which way you go, will always be continuous and it will stay the same. So moving on to the next problem that I wanted to discuss, I wanted to look into graph theory. So here I have a model from my second source called 356 Neural Networks. This overall graph theory is a neurological natural image and how our brains react to natural images. So as we can see, A, B, C, and D are different graphs that we can use, or doctors even use, to distinguish how our brains react to certain pictures and how we remember, whether we are conscious or not. As we can see overall from what this picture distinguishes, B overall is a more simple version of a graph. We can see that red is getting higher than blue, yellow is a little higher than red. And then when we look over at A, we can see that it's more of a cross correlation, which is more a linear aspect, as we can see that an overall negative effect when we look at a natural image. C overall, we can see data versus geometric. In my personal preference, I would prefer rather looking at a geometric version rather than a shuffled. The reason is because a geometric gives us very more accurate description of how someone would react to a natural image versus how someone would react to a shuffled image. And we can look into this and how this study is very important for human behavior, as we can look into evolution, we can look into gene regulatories and the stability of biomolecules, and how a more complex data gives us a more complex data. And for me personally, as I look at model D for our graph theory, I can see that it's a little bit harder to interpret, as it always, all the other diagrams go off of edge density, but the very last one doesn't really go into that concept as much. And we can look into how the study is carried into today, as looking at maybe a diagram of B is more helpful than looking at a diagram like D. And so, to conclude for my project, we can see that topological models and graph theory are shaping the neurological worlds today. We are trained from a very young age to what we learn and what we grow and how we are as human beings really carry on to how we turn into human beings today. And no matter if we go through good experience or bad experiences, overall, we do go through these experiences, and they are the ways we are shaped today. Whether you remember something from your short-term memories or your life experiences or your overall abstract memory, these things will come in handy when you need them. Our brain is more powerful than we think they are. Overall, the neurological world is growing, and so are we. Thank you very much.